on this computer. Okay, good. Okay. I shared that one. Okay, good. Okay, today that we're gonna continue the same discussion we had been doing for the last 3 weeks, same kind of a discussion, and then this week gonna be that last week, and then we are done with this class. Okay, so the final chapter would be that chapter 11. Chapter 11. Okay, chapter 11. We're gonna do the model comparison with the F ratio. F ratio we have already seen, but we're gonna do this one in a the kind of like in a broader range, okay, broadly. So we can have a look at it. Before that, let's go ahead and see what you have for your week 4 homework. Week 4 homework, I can make it available. And then week 4 final exam, it's as we discussed in the beginning, that it's going to be based on the chapter 11 review questions would be that there's a MCQ final exam. The week 4 assignment. Let's go to week 4 assignment and see what you have over there. Week 4 assignment will be conducted in, not in class. Okay. Download this RMD template. That's okay. Then we may pass one admission data. And yeah, we have RMD. If you go to this RMD, you can see that one in addition to, I think there's something missing here. No, there should be another. This one is missing. See? Hey Magnus, we just started. Okay, I'm just going through that this okay, this the homework. I made it available. You can see from your side. Okay.
Okay, sure.
Okay, yeah. So I think that something is missing over here. That's what I was wondering, because we should have we have a data, and then we have this one. Oh, we have that one. Okay, okay. That's why I was wondering. Yeah, we have that doc. Uh, doc one, this one RMD template. Okay, we have both of them. Oh, oh, oh. It's not something very weird. This one. Yes, that one. Yeah, this one, week 4 assignment, the doc one should be this one. I have converted that into, you're gonna have a doc one, I have converted into the PDF as well. It's based on that, this data set we have already seen, that admission data. See? We have seen this one. Okay. So, see, for each of the following variable contained in the below table, get the frequencies for each categorical variable. If they were categorical variable, get the frequencies. If they were like quantitative variable, get the mean and standard deviation. See? Research experience, categorical. Then you can say how many from the research experience, how many from how many students don't have a research experience. See? Frequency group 1, frequency group 0. Undergraduate GPA, then you can put the mean and standard deviation. Mean here, standard deviation. Letter of recommendation, mean, standard deviation. Standard, the statement of purpose. See that? Sometimes these one, they have a range like a very short range or short interval. Within that one, you have a like a, that not that many that options. In that way, sometimes you can consider this one as a categorical too, but for your convenience, either way is fine. If you're going to consider this one as a like categorical, still okay, because that we don't have that many options for given variable. If you go ahead and look at that data set, you can easily see that what I meant by that one. I'll show you. This is what I meant. Okay. New profile, one assignment, assignment, homework, before, admission data. You see. You see that if you go to statement of purpose, look at it's gonna vary from most of the see 1 to 5, let's say 1 to 5 with the increment of 0.5 with the increments of 0.5, okay, with the increments of 0.5, okay, okay. Hey Benjamin, that I just started, okay, I'm just going through that. I just made available the homework number 4, okay, you can have a look at it, that one. I'm just having a discussion on that one, okay, we didn't do anything yet. But I'm trying to say over here that this letter of recommendation and statement of purpose, if you want, you can consider even as like a categorical data, even though they seem to be like a quantitative, but still you can consider these two, letter of recommendation and statement of purpose, because look at, they're gonna range, their ranges. Let's say 1 to 5 with the increment of 0.5. See, because of that, you can consider that one as like a categorical of this one. Let's see. So if you go to the homework, I'm going to convert this one to E. This one, let me say, this. See, okay, install package. See, here, this is what I'm talking about. See, looks more quantitative, but few categorical categories suggest categorical. See, still. But here we were telling that if they were like a quantitative, you have to go to get the mean and standard deviation. Still, you can do that one. See, yeah, I'm gonna consider. Yeah, I'm gonna consider these 3 GPA for sure. LOR and SOP. Those are the 2 that I'm gonna consider this one as like a categorical, and then find the tallies as well. You can do that. That's what I'm trying to say here. So let's say fit a general linear model. So mean and standard deviation for the quantitative variable. See, quantitative variable, you're gonna find the quantitative variables, mean and standard deviation for the quantitative variable. Okay. So favorite step. Okay, I have to install this. See. Okay, then favorite step. You see, with the 5 number summary. From that one, you can extract mean and standard deviation and just put it over here. Okay, here. Sorry, I'm talking about undergraduate GPA and letter of recommendation. I'm going to consider in the first, in the primary stage, I'm going to consider this one as like a quantitative variable. This one and this one, both of them. Okay. So, see, that's why I'm going to find their favorite stats. So, LOR and SOP. Oh, and research for sure that categorical. For that one, I'm going to find the tallies. If you want, you can find the tallies for them too. Then you can see, look at their options. Not that many options, not that many categories within that categorical variable. You have 1, you have 1.5, you have a 2, 2.5, 3, 3.5, 4, 4.5, 5. As I said in the beginning, 1 through 5 with the increment of 0.5. In that way, you still can consider that one as a categorical. See, 1, how many ones you have? 6. How many 1.5 you have? 20. How many 2s you have? 33. 2.5, 47, like that. See, same thing you can do this one if you want to. In 2 ways you can talk about that one. See. Oh, I'm sorry. Screen share is not showing. I'm sorry. Okay, hold on. I'm sorry. I just show. I'm sorry. It's not sharing. It is not. You don't see that one? Anybody? Can you see now? Oh, I'm sorry. Okay, I'm gonna go back. Okay, go back. I'm sorry. Let me see what happened. Okay, yeah. I think now you can see, no? You can see now, I think. Okay, I'm gonna get back from here. Okay, this is the data set. This is the data set, okay? I'm talking about that statement of purpose and LOR. Letter of recommendation, since these are like a more like a categorical, because they're gonna have a like a values gonna go from 1 to 5 with the increment of 0.5, as you can see from here. See, okay, they both will kind of like a 1 to 5 with the increment of 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.55. It looks like a numeric, but still you can consider as a, like a categorical. So they, because of that, I tackle this one two ways. Okay, you know, up to here it's okay. See, first time I'm going to consider that one as a, like a quantitative. Okay, see? GPA for sure, quantitative. LOR and SOP. See, they both. And again, GPA for sure. Sorry. That one we done. Then favorite set. See, it's so their favorite set if you want. See, oops, sorry. What is that? No, 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 this is not right. Yeah, it's not right. See? So, and then tally. See, research for tally for sure. See, SOP is as a tally, as a categorical. This one also as a categorical. See, that's what I did. See? And as usual, that we can that get the frequency for each categorical this one, get the correlations between the outcome, chance of admit, and the explanatory variables. Put those values in the table below, label RP, perform multiple regression. Now we're talking about instead of regular regression, now you're gonna come, now you're gonna add all other variables together called the multiple linear regression. Okay. So admission data CSV file not downloaded. I didn't see your that message. Okay. You cannot get this one. Anybody? You cannot download this one? It's not accessible? Oh, okay. Let me see what happened. Okay. This one, okay. Let me see. Okay. Let's open. Okay. And see if it's not, I can upload. Oh my God. Yeah. What happened to that? Okay. Don't worry. I'm gonna this one, pull this one, and then yeah. It's not pulling my okay error page. Okay, good. How about the RMD? I want to double check that. Really, it was working. I don't. Let me check this one more time. Is it working? I think it's working. No? Yeah, yeah. Okay. Thank you. Thank you. Okay, that one of the data file. Okay. Okay. Good. I think now, yeah, it's here. I think this one works. Oh, hold on. I have to say, hold on. I have to say for you to see on your side. So equal assignment. Equal assignment. Let's open this one. I think it should be there. Yeah, I think it should work. Okay. Sorry that, yeah, because when you write something, because I had that one in another screen, I didn't see your message. Okay. Yeah, I think it works. Yeah. See that one, then little bit mm, this one, see. Multiple regression they see. If you have a one variable, simple linear regression. Okay, thanks. Yeah, thank you. Thanks. Yeah. Okay, see, now you can see, instead of looking one at a time, they're going to put all the variables through to that one and see that how it works. Okay, so it's called a multiple linear regression. Multiple linear regression, see, if you have one variable, we're going to call the simple linear regression. See, so if you have a see, y equals, let's say y equals b naught plus b1 x plus 0. See, this one simple linear regression. Simple linear regression. See, simple means what? Only one explanatory variable. Explanatory means x variable, x bars. Only one simple regression. I don't know why this pen has this issue. Regression. Yeah, it doesn't look like a recursive handwriting. Okay, I have to write each and every letter separately. Okay, so linear means it doesn't mean like you're gonna get like a straight line. Linear means like you are see. This is the right way to have a look at B naught and B1 are in linear form. B naught and B1. That's why we call linear regression. Linear, not because of the straight line. Okay, not because of the straight line. Sometimes see for this one even see under that simple linear regression we have that one. See, sometimes you have a see log regression. Sometimes you have see you can say log on y b naught plus b1 x plus 0. O log y equals this right again separate b naught plus b1 x. You're gonna take the log on the y variable to make it straight line. See, sometimes. Or you can say y equals b naught plus b1 log x plus c. So log y. For both of them, you can take the log. v1 log x plus c. See? Inverse regression. Sometimes under the same set, a simple setting, see, you use the one x variable. See, under that one, inverse y b naught plus b1 times 1 over x plus c. See? I'm using 1x. See? 1x. See? Only 1x. I have only one variable. See? One explanatory variable, simple. But under the simple setting, it's a simple log regression. Simple, see? Inverse regression like that. See? By, see? Then same, see? Look at this one. Polynomial. See? Polynomial regression. See? I have 1x, b naught, b1 x. But I'm going to raise that my x into the certain power. See? I can raise to the bk to xk. See? I can raise all the way up to k. Plus. Let's see what's going on. Connect. Okay. Y plus b naught plus b1 x plus b1 x squared plus dot plus x b2. I'm sorry, b2 b1 b2 b2 x squared like that all the way up to plus bk x to the power k. Plus same x variable being that you're gonna add by taking its powers and see which one gonna be the best one. This should be the b. Okay, should be b. Yeah, b k to the x to the power k. In addition to that one, here what we are trying to do, this is like a simple linear regression that I'm gonna say that one. See, first one, see, one, okay, Roman numeral one, and then under the second one, instead of that putting one variable, I'm gonna throw so many variables. See, it's called the what? Multiple linear regression. Multiple. Multiple means more than one explanatory or x variable. More than one x variable. Yeah, because there's something wrong with this book or that the pen. I think looks like the texture in the book does not speak very clearly. It used to like something wrong with the texture in the textbook. This book, right in this book. And to or x more than one. Then you can add different kind of variables. See? B0, B1, X1, this time X1, no capital or simple, doesn't matter. See, X2. VK, X also key, plus 0. B1, X1, plus B2, X2. See? B1, X1, plus B. See? That's the one that we were talking about. See? Variable. See? You have it here, B2, X2. See, B1, X1, B2, X2. Those are coefficients, B1, B2, BK. But here not like that. The coefficient different, but the same variable being raised to the power of that different powers, whatever the power that you want, and keep manipulating the same variable. Here not like that. You are throwing that many variables. It's called the multiple regression. This is coming under the simple linear regression, but under that one, it should be polynomial regression. Look at here. It looks like what? When you, let's say that you have so many, see, X1 on this axis, X2 on this axis, and dot, 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 see, Xk, see, here. Then what do you get? You're not going to get a straight line. It's going to be in the k dimension, not 2 dimension or 3 dimension, based on how many variables you're going to throw. So it will be represented by not a straight line, but by a plane. See, plane. See, it's a plane. This plane we're going to call hyperplane. See, regression hyperplane. So regression hyperplane. Its equation is nothing but, see, equation is nothing but y hat, see, y hat okay, y hat. Estimated value gonna go to the plane. Regular value gonna be somewhere in the space. Okay, I'm gonna write this one in easy way. B naught plus summation. I use the summation. This whole thing will be written by summation, easy. You don't have to expand. Summation. See, you can say x b I. See, I goes from 1 to k. Summation bi xi. So I would say I goes from 1 to k bi xi subscript. That's the same thing that we are talking about here. Instead of that working with one variable, we are like to taking into account all the variables and see how it's going to work. See, so first time you're going to put one at a time. So see, get the correlation between what and what. Chance of admit versus research of experience. See, chance of research experience and chance of admit. Undergraduate GPA, chance of admit. Letter of recommendation, chance of admit. Statement of purpose versus this one. Then what? See, then we're going to say perform the multiple regression. Put those values in the table, label RP. See, R you can produce along with the p-value, its corresponding p-value. We had a broader discussion in the previous, that all the videos, okay? So you know what the P is, what the R, they have, I did that one even in the 2 videos and then so many last week, you know, heavy range, okay? So they very elaboratively I explain everything. So you cannot miss any of this, what the P value means, what R means, everything's already there, okay? So it should be, see, let's say that before that one, let's say that I'm gonna go ahead and then factor this one to see instead of working 0 and 1, we're gonna go to no and here. See, string of data. Now it will be converted to what, and you can choose, and then you're gonna set the same thing. This is no years how you're gonna convert into 0 1 on the other hand. Okay, that's what I was showing. Okay, you don't have to do all of these, but I'm showing different things. Okay, factor, integer, numeric. I'm talking about which one, the research, no, research, integer 1 0. Here still 1 0. Why it doesn't? Yeah, see, correct. This is another way. Look at 1 and 2. If you do like that, what happens? Research F 1 and 2 0 will be replaced by that one. Still numeric. Let me see what's going on here. Okay, factor level 0 1 2. That's the research int. Okay, int. Now let's look at this one. Okay, research. See, I'm gonna get the research and research factor. They've been included over there. Yes, no, yes, no. See, three of them. See, we can get that one done in several ways. See, factor, recode, like that. Okay. Then let's do the. I'm going to talk about some kind of a centering. Yes, we are missing this one. Foxplot. No. What happened? Leave Foxplot. Yeah, GG formula. See, this one is not right. Okay, it's use of library. Maybe Foxplot. This would be, but what's going on over here? I'm looking for chance of admit. Research if why they not separate this one. Research if 0 and 1, 0 and 1, or this one. research factor, research F factor, factor. Two labels, no and yes. Okay. Either way. So I converted this one, now it become factor, research F. Research F, and I put it back into the data. And research F. See. Oh, yes. And this one again, see, if you have an OES, you can put it back into this one, and then 0 and 1 recode, see, 0, 1, 1 given to switch, see, 1 being replaced by 1, 0 being replaced by 1, 1 being replaced by 2. If you want, you can do right there, see. That one researcher, then we're gonna factor like this way, 0, 1 being like a, see. Why this is not working? Why this is not gonna split? Search here. Data that not gonna split. It should split into two parts, no? Because that this one has a yes and no. Okay, what I'm gonna do instead of this one, let's go with the research. We don't have to do any grouping, no? You remember Foxtrot? Chance of admit by this one, research should split continuous. Why continuous? That's why we split into that research F. That's why we make this one as a factor. See, research F. If I use the research F, it should work. It doesn't, let's say factor, it's gonna happen here. That's it. Should split. Yes and no. So here 0, 1, yes, no. Yeah, that's the same thing we did here. We using that one of these. I use this research factor, which is this one. Data research. It's the same thing. Why it doesn't work here? I'm gonna try the research factor 1. Let me see. Somehow. That's good. Works. So this one, level 0, 1. You don't need this one. You don't need this one. That's the same thing. Let me check one more time. I'm gonna have a look at it before I'm gonna take it out. Okay, research factor, data research level 0, 1 label. Yeah, that's the same thing. Okay. Then this is 0, 1. It's the same thing. I think this one is, I think mix up with this one because that it has been put it back into, see, I'm using the same name, see, same objective name, I think, see, I'm gonna know, yes, put it back into 0, 1. Yeah, that's why I think. So here, okay, this the way that you do one time, see, that's why they say I use the 1 and 2 like that. I'm here using the 6. If it is 1 and 2, I think it might work. research. Yeah, there you go. Yeah, that's why they mix up. Yeah, but I did that one with the same name, put it back into that one, and he gonna think that it's like a content. Yeah, so better off to give like a different names. Okay. Yeah, that's good. Yeah, so you can use this way or this way, doesn't matter. But this same thing. I was wondering why I did this one. Okay, this, and recode 01. It's the same thing. It's the same thing. Okay, now get rid of this one. That's the same thing. This is good. See? Okay, then correlation, see, co-test chance of admit versus this one, see, you can see. See, we're talking about this p-value. You should include that p-value, which is, you can simply say 0, okay? R is how much? 0.55, 32, or whole thing you can copy and then paste over there. Or just simply within parentheses, you put 0. Within parentheses, you put p0, okay? So those are to get this column, undergraduate versus chance of admit, letter of recommendation was that one. Excuse me. All this together. See, can get all the p-value as well as p-value is almost 0. See, corresponding value. You know what the t-value, you know what the degrees of freedom, everything, you know, confidence interval, this all print out. You can easily read and explain to someone else. Okay, I did that one last time. Okay, and part C, then that part B here. Okay, let's look at that one. Then in part B, okay, we when label put those over here. Part C, perform multiple regression. See, multiple regression instead of taking into account one at a time the way that we used to do. Pretty much get the whole thing together. Okay, let's get the whole thing together. See, chance of admit. See, model. I'm gonna say model 1 LM chance of admit tilde research plus CGPA plus LOR plus SPA data. Okay. Okay, summary. See, summary will give you each and every coefficient, be it B0, B1, B2, B3, B4. See, B1, B0, sorry, B0, B1, B2, B3, B4. See, those values are already given 1, 2, 3, 4. See, but they are interested in what? Only B1 only. See, B1. See, this should be B1. No, it's not right. This should be not B1. It's not right either, the way that they have said this. I didn't do this one. I double check, but I forget to do this part. It should be BI. Sorry, BI. 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 B. I. Sorry. BI. BI means a B1. You put the B1, B2, B3, B4. That's what it means. Okay. B1 here. See, that's the coefficient correspond to research B1. This printout, I'm talking about this value. See, this is B1, this is B2, B3, B4. Okay. Within parentheses, you should put their corresponding p value. See, this is p value. So you put the B0, let's say B0, we are not interested in B0, I think. Yeah, we don't need the B0. See, every time we are looking into that, all the coefficient correspond to their variable only. Okay, this one and its corresponding coefficient. This one coefficient. coefficient. So you have four of them. Within parentheses, they are corresponding p-value. Why they have a p-value? We had a broader discussion on that one because they are random variables. They are variables. You can draw the, even though this is the observed value, you can assume that this can be done by several people. In that way, you're not going to get the same B naught or B1 or B naught through B4. We're not going to get the same value for those coefficients. They're going to vary. Because of that variation, you can draw the histogram, from the histogram. You can talk about the p-value. You can talk about t-value. You can talk about standard error. Standard error is nothing but they are distributions, that particular distributions, not one value. There are so many b values. If you're going to generate this one, let's say 1,000 times, 1,000 of them. Out of them, if you draw the histogram for each and every one, they are corresponding standard errors. See, these are standard errors. This is the t-value. You know what the t-value is. We had that discussion as well. Okay, t-value is the one that we're going to utilize in order to estimate this one. That means simply this one divided by this one. P-value is nothing but the probability greater than this value. Okay, I'll just go through that one more time. Okay, in that way that can be applied to, okay, I'll go through only for this one, then you can go through, you can apply the same concept for all these coefficients. So this is for BI, inside P value, and the lower bound and upper bound. Whose lower bound and upper bound? B's, okay? This guy, confidence interval. Whose lower and upper bound? We talk about so many lower and upper bounds. See, it should be definitely, are we interested in the lower and upper bound of R or B1? That's the question. R has a B confidence interval. B not also have a confidence interval. See, look at R. R has a confidence interval. But the way that this being worded over here, they set this up, okay? Set this up. We are interested in the confidence interval for each and every coefficient. Put the coefficients confidence interval. Can you find the confidence interval for B0? Can you find the confidence interval for B1? Can you find the confidence interval for B2, B3, B4? See, like that. But in R, you see, now what are you going to do? See, I'm going to write, no, see, confident. See, I'm going to write the confident. See, let's see. That's a summary, confident. Confident will give you the what? Each and everyone's confidence interval. This one gives the point estimates. These are interval estimate for each and every coefficient. See, and every coefficient. We had that broader, very heavy discussion on that one the other time. See, can you remember last time? Okay. So these are the coefficient. Okay. I can get into that one next time, but because these are like a multivariate. The multivariate case, you tackle all at the same time. Okay, that's okay. See, but here, so put the confidence interval here, upper bound, lower bound, upper bound, lower bound, upper bound, lower bound, upper bound, lower bound, correspond to this guy. Okay. Now, if you want, you can get the correspond to this guy as well, R instead of R, but it's not clearly mentioned. That's why I have a confidence interval for. I'm gonna write it. So, data, sorry, data, beta I. Okay. Beta, if I do, it's gonna come back. Okay, I'm gonna say beta I. Okay, beta I Italy. Data, this one, so data, so data, I, data, no, I, data, I, okay. Data, okay, good. Data, I, then on your one, I don't think that you have a PDF form, that file for this one, because it's in the Word document. This is something that I converted. If you want, I can upload that one too. Okay. So here you have, I think this one, which was Simon. Oh, it's a Word document only. You can do that one easily on Word document, but if you want, I can put the Word doc, the PDF as well. Okay. So, now we have a PDF. Otherwise, you have to convert using Adobe Acrobat. Yeah, I don't think sometimes you might have or you don't have. Okay. So now you can have both of them. You can see. Okay. Before assignment. Okay. So I'm since I opened this one, that's what I'm working on this one. So these are for the betas. Otherwise, you might be thinking it might be for the R between this one and that confidence interval between, because you have a confidence interval for betas as well as that R. Okay. Because when you run this one, you see, with the confidence interval for R between chance of admit and the other one. That's not what we meant. We meant that give me the confidence interval for this one. How do you get that one? See, you're gonna set that you fit in that one to the model, and then you get the confid. See, look at here. Other interesting thing. You run ANOVA. Okay, ANOVA. They say here. See, you get the type 1. This is type 1. I'm gonna get in over there. Type 1. See, you go over here. Supernova. Look at what you get. Oh my God. Supernova. We have to stop. Okay, go to supernova. Okay, I'm gonna run. See default. Okay, look at default. They say type 3. I want a little bit talk about this, and at this stage now I want to talk about it, because since we are talking about the multiple regression, all the regressions. Okay, here, see here, if you want type 1, that would give you type 3. If you want type 1, you have to type in type equals 1. See, Roman numerals 1. See? That will produce type 1. See, I'm here, type 1 SS. Let's see what these means, okay? If you want type 2, you go to type 2. See, type 2. Look at, they are all not gonna produce the same value. So what? Let me see. Okay. SS 0.000. 2 point, look at here, 6.386, 2.483, research 0.090. See, look at what happened. They change. 0.090 here too. If you run NOVA, look at the, that's what I'm saying. You get type 1, okay? That's what I want to tell you. If you run ANOVA is type 1. What that means, see, type 1. Let's put the type 1, okay? I'm gonna run the type 1. Are they the same? Yes. Are they the same? Here, see, research, 2.48333, 2.483. CGPA, this one, sum of square, see, sum of square. See? See? Next one, 0.097, 0.097, 91, 0.005, see. In addition to, you have 1.72 residual on the top. In this ANOVA table, it's going to show you something. See, the model error reduces this much. Your regression is this much. SSC, SSR, SS total. In addition to that one, now you will see four other, see, these four. The research, CGPA, LOR, and SOP, for them individually, they have their own sum of squares. But those sum of squares not going to be same if if you run ANOVA and then they're supernova, they're going to change. But what I'm trying to say that ANOVA, by default, ANOVA will give you type 1. It is same as you are running that type 1 using supernova. But if you run supernova without typing this one, that will give you type 3 by default. See? By default, that will not is that the same thing? No. See, look at here. Research 2.483 type 1. Type 3 what? 0.090. Type 1, 3.81, 1.616. Type 1, okay, this type 1, okay, this type 1. Okay, type 1. This is type 3. See, this is by default. By default, you get type 3. But if you want type 1, you get the type 1. It is same as what you get from this ANOVA. In addition to that one, there's another one called the type 3. We have to have a look at it, what this means, why they differ from each other. See, this table should be taken to and then analyzed and see what's going on over here. Okay, let's see. Second. I'm gonna say, okay, that's something very clear here. We'll come back to this one, okay? Decomposition, see? Sum of squared regression, see? SSR. Okay. Let's say in our case, we have B0 plus B1 research plus V2. V2 is what? This one on my side. I'm gonna open this one. V2 GPA CGPA plus research V2 CGPA plus B3 times letter of recommendation LOR B4 statement of purpose plus error. The same thing I'm gonna write for my convenience with the aid of I'm sorry, this one instead of Y is supposed to put Y. I'll say the chance of admit, okay? Chance of admit, what they say? chance of admitting. Chance of admit. Chance of admit equals like that. Same thing I'm going to write with the algebraic form with the y is admit y b naught plus b1 x1. X1 means research, b2, x2 means CGPA, x3 means a letter of recommendation, b4 means x4 statement of purpose e. Okay, right there. The same thing for my convenience. Some people they refer to they like to write this way too. X naught c plus b1, x1 plus b2, x2 plus b3, x4 plus e. If you want, you can write. There's nothing wrong with that one at all. Okay. B2, 3b, 3b3. Sorry. So x1, x2, b4, x4, b2, 4 plus error. That's another way to write. Most people they write b naught plus, as I write earlier, see summation notation, bi xi, I goes from 1 to 4. That's the most concise way of writing this. It doesn't matter. Okay. So let's look at that. What do you mean by the decomposition of sum of square regression? Okay. I would say regression sum of square, which is called SSR, can be partition. Can be partitioned into pieces. Okay, pieces that mean in any order. SSR can be partition. Partition can be partitioned into pieces. In order. Okay. Look at what I'm gonna do. I'm gonna say SSR. I'm gonna write this one in this form. I say with the aid of all the variables, 4 variables. This is the proper way of writing SSR later on. Is something like SSR being calculated. It's equivalent to SSR being calculated only with x1. See, if you're gonna run this regression, if you're gonna fit in this regression only with one variable, first variable, let's say the research variable, and then if you get that regression, sorry, SSR, that can be easily added to the other one. See, I'm gonna keep adding. That's called the decomposed. See, SSR. Now you keep adding another one, second variable, given that x variable is already in the system, already in the equation, already in this formula. Okay, already exists. Okay? This means given that. This line means given that. That means you can say x2 given that x1 is already x1 has already been taken into account. See, already in the system. That's what it is. SSR given that line means that one plus okay, system plus. Yes. Right. Now what are you going to do? Plus SSR. I'm going to add the third variable. See, one variable at a time. Given that x1 and x2 are already in the system. See, x1 and x2 are already in the system. Already you have taken into account. Okay, plus. And the last one, SSR x4, given that x1, comma, x2, comma, x3. That's what it says. That means you're going to add one variable at a time. It is very related to the variable selection method. You're going to learn this stuff down the road in maybe starting from 620, 25, 30, those classes. But these are, this being decomposed. Look at the summation of this guy plus this guy. Okay? Plus this one will add to SSR. So these are called, see, these are called the sequential sum of squares. Sequential. Okay. See, this, okay, I would say this particular breakdown, okay, for type 1 sum of squares. SS, type 1 SS. Breakdown. Okay, breakdown. Type 1 SS. That means variables added in an order. These are called, see, those are called extra sum of squares. These are called, look here, extra sum of squares, extra, or sequential sum of squares. What that means, then now you might be thinking, how could you gonna calculate this one? How they calculate this one? This one, let's say this one, SSR x2 given x1. This one, you know that you're gonna have a, like only one variable, only researching that equation. You have taken into account only explanatory variable, only one, which is research, and then you can fit in that data into that simple linear regression. But how about this one, SSR x2 given x1? What that means? How do you calculate? How they have calculated and given us that answer? Where this coming from? So see, so extra sum of squares. Sum of squares, how do you calculate? Let's say that you are interested in SSR x2 given x1. Let's say this is the one that you are interested in. SSR x2 given x1. Sum square regression, and then already you have x1, and then you are systematically add another second variable which is x2, and see that you're gonna see some kind of a regression, sum square regression. How do you calculate? That's nothing but sum square regression. Sorry, sum square regression with x1 and x2 both. See, sum square regression being calculated for that two variable regression one minus sum square regression for x1. Whatever you have in the denominator will be taken out. See, it is equivalent to, instead of measuring sum square regression, you can go to SSE. SSE of, but you put the opposite. SSE of x1 minus SSE of x1 and x2. That's how you got that value. You can check that one. You can see clearly. I think on R I have done that one. Okay. That's how you get that one. If you want this SSR x2 given x1, you have to fit in that your data into like a two variable regression line. And from that one, you get the SSR and then subtract sum squared regression being calculated for the like a simple linear regression in which that you have taken into account only one variable. It is equivalent to same as like a instead of taking, see, higher the value of SSR, lower the value of SSR. They were inversely related. Because of that, see, instead of that SSR, you can take in the SSE. In a similar fashion that you can keep doing that one, but I'm going to show for the other one. So the two are going to write for your convenience. SSR, see, x3 given x1 comma x2. See? You say that already that this one done, x1 and x2 already in the system. Now you're going to systematically add the third variable and see how it, whether this is going to be the best fit. See, these are called the selection method. We have so many selection methods: forward selection, backward to elimination, and stepwise. So many methods you're going to take into account down the road. See, it is nothing but sum square regression is being calculated for x1 comma x2 comma x3 minus sum square regression from the variable that are in the denominator. Denominator means like I'm referring to this one as a denominator, x1 and x2. See? It is equivalent to, instead of regression, you can think about the sum squared error. Sum squared error of x1 comma x2 minus sum squared error of x1 comma x2 comma x3. The same way, sum squared regression x4, now x1, x2, x3 in the system. You systematically add the fourth one and see whether that will produce some kind of a that advantageous that situation or advantageous explanation for the y variable. So this is nothing but sum square regression. Now you're going to take into account all of them, x1 comma x2 comma x3 comma x4 minus sum square regression of x1 comma x2 comma x3 is same as sum square error x1 comma x2 comma x3 minus sum squared error of x1 comma x2 comma x3 comma x4. Okay, let it write like that. x1 x2 comma x3. SSC x1, x2, x3, x1, x2, minus 3 minus SSC of x1, x2, x3, x4. All of them. Okay, you know what I meant. Okay. Sometimes something. Okay. That means what? If you go ahead and look at that, let's say that this is related to type 1. Type 1, no, related to type 1. So this is the type 1. Yes, type 1. Type 1. Actually from here. Type 1. Type 1. Type 1. Look at type 1. Let's say that what we can get from the type 1. Yeah. See, type 1. You see, you get type 1 from Nova. You get the type 1 from this one. Okay. Let's say I'm going to run. It's easy to have either way is fine. Okay. Let's go ahead and get the supernova type 1. I'm going to run type 1. Look at this one. SS, this one, this one, this one, and this one. They should add to what? 6.386. This is the decomposition. It's a decomposition. See? 1, 1, see? Some decimal places 3, 2, 5, 5 plus 1, 6. See? Some decimal places been taken out. Okay. So these will add to, I'm talking about this. See? This is what? SSR research. SSR research. SSR research plus second one what? SSR CGPA given research plus third one, third variable, systematic SSR of letter of recommendation given that research and CGPA already in the system. Plus SSR for the fourth one, letter of recommendation, statement of purpose. Statement of purpose given that these three are already in the you already taken into account, exist in the system. See, if you add this one, and this one, they will add to that 6.386. Let's say this one 6 because that it has been rounded. Okay. So let's say this one 5, this 9, 1, 10, 18. See? 18, 8 for 4, 4 plus 1, 13. 2 plus 3 is 5, 5 plus 1, 60. Is that the same thing if you run the Nova run and see? Nova run, they don't split into such a way that we really need. See? So look at that. When you run a Nova, what do you see? You just simply see that sum of squares. These are not sum of squares. These are sequential sum of squares. Okay. So you don't even see that sum of SSR. See? You don't see SSR. But if you want SSR, you are supposed to add this guy, and this guy, and this guy together if you run a Nova. That's what I'm trying to say. It doesn't show very clearly the way that it's being shown over here. See? Look at the model, means SSR. This is SSR. If you SSR is how much, its breakdown has been given. That at this stage, we don't call this one SSR. These are called the sequential sum of square. Sequential sum of square of research, sequential sum of square of CGP, sequential sum of square of LOR, sequential sum of square of the statement of purpose. Then error, SSE, that's how, then SS total, very clear. That breakdown and their addition, see this way. In addition to that, you're going to add these four together to get the SSR. SSR plus that SSE will give you SS total. Okay. This plus that will give you total, not all of them. Not all of them. You see, if you add all of them, see 6, 8, and 8, 3, 11 something. See? This one plus this one will give you this one. This is the model has been broken down into 4 pieces, which are called the hierarchical. Sometimes we call the hierarchical or sequential or extra sum of squares. Do they have their own degrees of freedom? Yes, because one variable at a time. See, one. Degrees of freedom means number of regressive variable in the system. How many regressive variable in the system? 4. See, 1, 2, 3, 4. Or one more see, one more than the number of that regressive variable in the empty model. Can you remember? We can compare with that empty model. That one, see, anyhow, see. But this one is what? N minus number of regressive variables. See, error is n minus how much? 390. How many variables? We have 399, no? 399. Is that 399? This two. Oh, 400. I've seen 400. Let me see. Should be 400. Yes, 401. See. So this one n minus number of parameters to be estimated. N minus p. We know that one. N minus p. See. P stands for the number of parameters. Parameters are how many? 1, 2, 3, 4, 5. Okay, I come to that one. And total is what? N minus 1 for sure. See, 400 minus 1. See? This one is 2.483. 3.83. I'm talking about this value. This one. This one is how much? SSR X1 is how much? This value. 2.483. How about this value? This value. That value. Okay. How we got this value is the discussion we are talking about here. How they got this one like this way. That's the equation being embedded within that R program to calculate this one. So simply by looking into this one is not enough. You can say that where they come from. You have to have that kind of knowledge all the time. It came from this way, see. This way. That value has been already given. SSR X2 given X1 is how much? X2 given X1 is nothing but 3.811. SSR X3 given X1 and X2 is how much? 0.091. This one is how much? This is SSE. SSR. See, they will add. Okay, that's type 3. Oh, sorry, type 1. I'm sorry, type 1. Okay, type 1. Okay, let's little bit looking into type 2 and 3. Okay, so I'm gonna say type 2 SS is kind of the same as type 3. Type 3 SS. Okay. Type 2 sum of square refers to variables. Your variable added last. Okay, last to variable added last. Variable variable added last. Okay. These do not add to the SSR. We do not. That means what? There is a SSR. We are talking about SSR. X1, you're gonna add thinking that you have X2 and X3 and X4 are already in the system. You add that particular one last. Whatever that you are not interested in being added, whatever you interest one being added at last. X1 given X2, X3, X3 already in the system. See, the other earlier we didn't do that way. Earlier we do. See, we're gonna add that one first. See, first add X1. See, X1 and systematically add X2 given X1 only in the system. Here not like that. It will be added last. See, these three are already in the system and you're going to add the X1. That's what you're going to see when you're going to run type 2 in the first entry. In the second one, SSR, you're going to add X2, assuming that X1 and X3 and X4 in the system. See? And this one, X3 will be added, assuming that X1 and X2 and X4 are in the system. The last one would be fourth entry, fourth variable will be added by assuming X1 and X2 and X3 are already in your system. That those are, they do not add to SSR. They do not add to SSR, X4, X1, X2, X3, X1, comma, X2, comma, X3. Type 1 and type 2. So if you go ahead and let's say that by default, you get the type 3. Okay, let's go to supernova. By default, see, do they add 0, 9, 1.616, 0.65, 0. Do they add to 6.36, 6.36? No, they do not. That's why we are called this one this one is like a research, given that CGP, LOR, and SOP already in the system. Second one, this entry is nothing but CGPA SSR of sum square regression of X2, given that you already have this one. Now, on the other hand, now you know that how to calculate this one. I'm not going to write this one. If you have something like this, you know how to calculate. How do you calculate this one? This one, the whole thing, see, minus, see, you can split it to see, whole thing divided by SSR of all these minus the SSR of this one, okay? But what I'm trying to say, the main point over here, they do not add. Okay, this is type 3 by default. And if you run type 2, see, type 2 has the same thing, same like a type 3, see. 0.090, 0.090, 6166, 1.616, 0.065, 0.006. Type 3, type T, yeah, that's the type 3. Where's the type 2? Did I run the type 2? Yeah, see. This type 2, I'm sorry. This is type 2. This is type 3. See, they both the same. But they do not add to that. See, but the type 1 is not the default for the supernova. Default is type 3. Okay, but if you want type 1, you can get it. Once you get the type 1, they will show you the sequential one. That's the discussion built up over here. So actually I show pretty much everything over here, see, by calculating how they were, see, here you can see. Okay, you don't have to show that everything to me, but I'm showing you for you to get an idea that how that got that got. When you watch this one again, you can have a look at it, and then you see I put pretty much everything. See, see using the ANOVA, you get that one. See, I ran one at a time. The way that's it. I ran this. See, I ran. Look at what I did. See, this one. Chance of admit this one is lower. See, this is same as these are the same as sum squared error. I done this one, the error, 3 of them minus all of them. So with these 3, I ran that one regression and got the SSE. That SSE minus this one. You can do that regression model with these 3 and these 4 and go to the ANOVA table and then get those one and then similarly calculated. Okay. Type 1 SS. Okay. So look at this here. Now we're going to build up a different kind of a setup. Okay, look at, I'm going to run this one. When you run, go to summary. You have a serious issue here. Negative value. What that means? I mean, like, what that's trying to say that when the research, no research, GPA 0, letter of recommendation has like a 0 value. It's a statement of purpose. You're going to get what? Chance of admit is negative. Chance of admit cannot be negative. See, this is fine. But how do you, this theoretically fine, theoretically okay. But how do you have a negative chance of admit when research 0, CGP, LOR all zeros? It's the intercept. Intercept is the negative. How do you, maybe this one, see? Oh, intercept negative. What are you going to do? You're going to center in this one. Look at, I'm centering this one, okay? I'm going to get the mean of CGP. I'm going to get the mean of LOR. I'm going to get SOP. See, I can subtract that one, the mean, okay? Or you can subtract, see, instead of measuring that one from 0, you're going to go ahead to that center, and from the center, you're going to measure that you're reading. That's called centering, okay? Instead of measuring with respect to 0, you are trying to measure that one with respect to 8.6. Or any value, whatever the value you think of that, okay, I'm going to relocate that my 0, my reference point, I'm going to relocate. When you measure something, you have to have a reference point, reference line, or reference framework. That one you're going to change. That's called centering. See, the most important, the most probably that we can get this done using the mean. But here I tried another way. See, okay. GPA. See, if you subtract this one, I'm gonna call this one now centered GPA. Sorry, centered CGPA centered. This C for centered. This CGP already over there. I subtracted 8.6. Why I subtracted 8.6? Let me see. What is the mean? 8.5. Can I subtract 8.6? Yes. Assuming that one. See. Let's go to the LOR average. 3. Can I average? Instead of average, I'm thinking I'm going to subtract 3. Can I subtract that 3 again? 3 point instead of that one? Yes. See? Now, 0 on CGPA is for someone has a CGPA 8.6. If somebody has a 0, means is 0 on CGPA is for someone who has a GPA. So, sorry, GPA if 8.6 means 0 now. Okay. Now, 0 on LORC is for someone who has a LORC, LOR3. If somebody has 3 means 0. Same thing like that. See? So I've created these 3. Center. CGPA. Then I'm going to go ahead and then get the mean of CGPA. CGPAC, centered one. Look at the mean. Look at the mean. Look at the mean. Then I'm gonna fit in with respect to those variables. See, CGPA like that. Okay. That's what's gonna happen. Get the sum. See, negative gone. That's how you get rid of negative. So anybody who has like a zeros for pretty much everything, they still have what? Instead of going with the no, you feel like, okay, this doesn't make any sense. I have a negative. Well, how could I'm gonna remedy this situation and explain to my boss or audience? See, you're gonna say no, just don't worry. Negative can be taken care of. That doesn't make any sense. Even though that they have like a 0 GPA, there's no negative chance of admit. There's no such thing. That doesn't make sense. If you want to that make sense, that value, you're gonna get into what? See, now 0 means what? 8.6. Okay. Careful. Anybody who has 8.6 will be considered as a CGPA 0. Anybody who has a 3 means 0. See the way that we set this up. See? Now the intercept, which is 0.694533, is for someone who has no research. No research. See? LOR3 and SOP 3 and CGPA 8.6. No research too. See, research, no research. See? But I'm not gonna go ahead and then center in that is research. Research is categorical. Okay. Research part is categorical. You don't have to worry about that one. It's all taken into account at that no research. CGPA this one earlier, but now not. That's not the way how you interpret. Now you're gonna say this intercept is for someone. Earlier intercept is what? Earlier you say the intercept for somebody who has a no research, GPA 0, LOR 0, and SOP 0. Now not like that, the way that this has been revised in order to get like some kind of a number that for intercept that makes sense. We did that kind of adjustment, centering. Okay. Excuse me. So see, research CGPA, this one. Okay. Supernova. You want run. Confidence level, NOVA, those things. Okay. The slope coefficient do not shift. See, you can see the slope. What that means. See, what that means. What do you mean by the slope? What are the slopes? See? Slope are that D0, D1, D2, D3. Those are the slope with respect to see that when it comes to that these axes. Let me see here. Okay, they run before that one. Let's run this one summary. Okay, let's run without doing centering. Okay, let's see 0.02. Okay, 0.02. Is that the same value we get that one? Oh no, I'm sorry, I'm at the wrong place. Summary. I want to go to summary. Summary. See 0.03. Okay, this is the one. Okay, this is the one without doing centering. After centering, this one negative. That's why we will remedy this one. Okay, we did this one. Now I'm gonna run this one. Okay. This is the new variables. Only difference. See? This one I'm gonna compare. See, negative value becomes positive value. But the rest 0.035506 stays the same. 0.169258. With centering or without centering, the coefficients, the slopes stays the same because this is a ratio. Because of the ratio, they stay the same. See? The slope coefficient do not shift. They stay the same. They are still a 1 unit increase. Think about the regression line, a unit change in the constant because it is a linear. Okay, but intercept 0.69. You can't have a negative chance of admit, just like you can't have a 0, LOR, SOR, or GP. Okay. Now what are you gonna do? Now we're gonna think of in terms of the model equation. We didn't center research. Okay. Now intercept, new intercept is nothing but, okay, all intercept, okay, look at all intercept plus 0 research, see? Research slope. What is the research slope? 0.355, it didn't change. Plus, see, how do you get the research 0? The GPA 0 by 8.6. See, that's the one that I subtracted. It should be multiplied by its current slope. Doesn't matter that with the new model or the previous model, before centering or after centering, slope's not going to change. In that way, it doesn't matter where you extracted this GPA, this one. What I'm trying to say, your new intercept is same as by going through this equation. See, 8.6 GPA of the slope B2 and 3 times means this 3. Okay, how much that you subtracted in order to do the centering should be taken into account times the slope 3, and that will, if you multiply all these, they will come to the new slope. See, that's the trick. So that means this all the structures, they are built up in a certain way that the heavily mathematics have been utilized in such a way that you get a very beautiful answers at the end of the day. So, but you don't have to worry about that. What I'm trying to this one unmask for you to see something. Okay, so what you simply gonna do, you do the centering and then have a look at it, but you gonna know that what's going on behind that one. See, if you really want to know the intercept, you go to the whole intercept at the whatever you subtracted for research. Serious research, how much you put 0. Time research slope. Research slope is this one. See? It doesn't change whether you did the centering or not. Can I subtract? Can I subtract instead of that one my own mean from that one rather than just say 8.7? Can I subtract? Yes. See? Simply rather than 8, I'm gonna go with something very make more sense. See, 8.6. Rather than that one, I'm gonna say I'm gonna subtract my mean of that guy, and you're gonna start that measuring everything with respect to the mean. See, so now you have to have this much for that to become 0. See, you can do that way too. See, either way is fine. See? And then see, there are means you can calculate. See? And then you're gonna fit into that one and do the same thing. See? See? So now that new one is sorry. Now the intercept, which is 0.790, is that 0.790? Did I get that one? Yes, my supernormal. That's right. Yeah. Must be not. Which is 70. Let me see. Yeah, see, intercept, sorry. See, intercept 0.7. See, this one for someone who has no research, LOR is nothing but LOR is the mean of LOR. SOP is nothing but the mean of SOP. GPA is nothing but the mean of CGPA, which is this one. Whole thing being taken account rather than just you specifically pick like some part of that value. So you just say, I don't like this way. I like this one makes more sense centering. Rather than measuring everything, you go to 0. Instead of 0, you start measuring from the center. That's called centering. You're going to shift you that, let's say that this one, you're going to shift. See? Let's say that you had this, see? This one, see? You have this one, x1 here, x2 here, x3 here, x4 here, see? This one, y. See? Y is chance of admit, x1 is research, x2 is CGPA, x3 is like a letter of recommendation, x4 is like a statement of purpose. See? See, now it is in which dimension? 1, 2, 3, 4, 5. See? 5 dimensions. See? It's in the 5th dimension. See? So instead of go to the x1, they say x1, then if you measure with respect to this one, you go to its center, see, center, x1 bar. You go to x1 bar. Instead of measuring from 0, you go to x2 bar. See, x2 bar. x3 also x3 bar. x4 also x4 bar. All the measurement. You're going to shift that one. So you do all the measurement with respect to their center rather than 0. See? Then you have this one, you can have a what? As I said over here, not a plane. Plane is for 3 dimension. After 3 dimension, we don't say the plane. We say hyperplane. See, hyperplane. See? Dimensional hyperplane. So we are talking about this one. And everything 0 with respect to this one. That's my intercept. So B1 is what? B1 is, let's say B1, I'm going to take into account this one, X1, see? B1 is nothing but taken into account and see how my plane is inclined with respect to this X1, see? This inclination, see? That inclination, see? This inclination for B1. Okay? And in a similar fashion, you can think about X2, X3, X4, X5 like that, okay? Hyperplane. It's like that. That's what we call the inclination of beam slope. Slope with respect to x1. See, slope with respect to x1. You know, I use that abbreviation all the time. WRT with respect to x1. In a similar fashion, we can talk about all these. We talk about that one interpretation, you know that's easy because we talk about those interpretations all the time. Interpretation for this one, you know. And one thing that you have to, I'm going to come back here again. That pre, this is now you have that. Now again, you might be wondering what do you mean by pre? There are so many pre-f values. See? Let's go back to that. Okay, let's go back to that multiple regression. Okay, without doing centering, without centering. Let's say here we are here. Okay, I'm going to go back to here again. Okay, I'm going to go ahead and pull out that supernova. You know that supernova will give you type 3. If you want type 1, the discussion we had done in broad range. Okay. And these are we done too. See, look at this one. You might be thinking, what is this one? See, little bit this one. See, this is the estimate. This is B naught. This is the standard error of this guy. It's the T value. It's the pre-P value. I do this one little bit. Okay. So I do the common one. Okay. I say that before I move to that one, see, let's say that your BI, okay, BI, I can go from 0, 1, 2, 3, and 4. BI, see, see, and BI, then you can see N equals sample size. Let's look at this one a little bit. I can say K, number of regressors. Regression is an explanatory variable. How many explanatory variables? This one 400. Number of regressor variables. X1, X2, X3, X4. So we can use number of regressors or explanatory variables, same meaning. Okay. So my convenience, I use the regressors. X4. the key, and the P, I would like to see number of parameters to be estimated, actually, to be estimated. Those are what actually? Beta naught, beta 1, beta 2, beta 3, beta 4. They are estimates B naught, the point estimate, to be estimated. Be estimated beta naught, beta 1, beta 2, beta 3, beta 4. And this equals 5. Estimated 5 to be estimated. Beta 2, beta 3, beta. And then point estimate. So that guy is nothing but B naught. This guy is what? B1, B3. All are that with that ANOVA table, you have this one. B2, sorry, B2, B3, B4, see, B4. B1, B2, B3, B4. And the interval estimate. Interval estimate. Interval estimate is confidence interval for beta 1. See, those are given. Confidence interval, sorry, beta naught, beta 1, confidence interval for beta 2, confidence interval for beta 3, confidence interval for beta 4. They were given already. AI beta 1, AI beta 2, CI beta 4, CI beta 1. They were given, already given. You see, their confidence interval are given. See, their confidence interval are given. See, I'm sorry, no, not that one. You go to the confidence, you'll give that one. Interval estimate. These are point estimate. These are point estimate. I'm a little bit try to explain this one just a little bit. See, these are given. See, this is B4. And can I draw that histogram for each and every one? Yes. Can I get the bootstrapping? Can I get the bootstrap sample for B1? Yes, we know how to do that. Can we get the bootstrap? Yes, B1, B2, B3, B4. Bootstrapping. With the bootstrapping or simulation, can I draw the histogram for that one? Yes. To represent all this, I'm gonna draw this one for histogram for the BI. So I goes from C to BI. You know, I goes from 0, 1, 2, 3, 4. So that one, can I draw the histogram? Yes. Can I get the smoke flow scheme in top of that one? Yes. Would that be bell shaped? Yes. According to what? Central limit theorem. See, bell shape, symmetric, bell shape, symmetric, and bell shape. Distribution, sampling distribution, we can say sampling distribution of BI. Okay. Ampersand, okay, here. Does it have like a center? Yes. What do you have for the center? Center distribution of BI. Center means what? Mean of BI. Look at mean of BI. How do you write mean of BI? Mu of BI. They think that's another way of I'm gonna write this one. Expectation of BI. See? EI. In the long run, what do you get? BI. See? Expectation. It is same as what they think. It is same as what? The parameter to be estimated. Beta. That's what they think. According to this one, according to CLT, see? Due to CLT, central limit theorem. This normality is due to CLT, beta. Since you don't have a beta, you go to its estimate. See? Since estimate is nothing but BI. You don't have too many BI, you have only one BI. Because of that, I'm going to say, I'm going to go to the BI of observed value. See? That's the same thing. What is that? That's the center of this one. That's the point estimate. See, this is your B naught. Obs. B1 obs. B2 obs. B3 obs. B4 obs. Like that. And on the other hand, do I have a spread of this distribution? Spread. Yes. Spread is nothing but standard deviation of BI. That means sigma of BI. I'm sorry, sigma of BI. Sigma of BI. BI. But don't use that one, that y bar divided by square root over here. Those are that equation very heavy, but I'm not going to write over here, okay? So each and everyone has their own spread. See? Their own spread. Do you have that one? See? Sigma B1 naught, sigma subscript, see sigma sub B1, sigma sub B2, sigma sub B3, sigma sub this one. You got that? Then what is this t value? T value is nothing but you really need to check this one. This can be related to your testing of hypothesis. That means each and every VI can be tested and see whether they are contributing that particular, not the coefficient, but its corresponding variable is contributing significantly to the explained that variation of chance of admit, see, versus its counterpart, HA, BI, not equal 0. See, data is not equal 0. I goes from, you can apply this one from 0, 1, 1, like that. See? In order to do this one, you need a test statistic. One we're going to call T. T is nothing but simply your BI ops, see? Ops divided by sigma BI. This one also I'm going to say, see, I'm going to add to this one. Sigma hat BI, if we don't have that one, in that one you can say SBI. Okay. S sub see, since it's unavailable, see, you can see it's sample S. Okay, that they divide by that one. This one be this one is the they see, mean divided by standard deviation is T, nothing but see T is nothing but mean of BI divided by standard deviation of BI. That's what we are trying to say. Simple. Okay. If we then look at this one, you can see this one divided by this one is see this one T value. Same thing. This value divided by this one. This one. You really need that one to decide the P. That P you really need to decide the whether you're going to accept H0 or HE. You know that. I discussed about that one in previous. To test whether you're going to accept this one or accept this one. Reject. We go with the rejection. Whether you're going to reject this one or do not reject. That one will be decided by your P value. How do you get the P value? You're going to set this one into, go ahead and say, you're going to set this one into a normal distribution. See? Normal or T distribution. Let's say T distribution with T distribution. With what? How many degrees of freedom? Degrees of freedom is nothing but error degrees of freedom. That's nothing but n minus t. N is how much? 400. T is how much? 5. 395. Okay. So you go ahead and locate. I'm going to say this one T0 for my convenience. Absurdity. So I'm going to put this T0 here. T0, see, and see this one, the area to both sides, okay, this 0, this one negative T0, is both. See, this area together I'm going to call the p-value. P-value is nothing but probability that p-values are extreme than the T0. So you have to double that one. It's nothing but 2 times probability T greater than T0. Okay. In R, you can write this one 2 times PT, area to the left of minus T0, it's easy, and degrees of freedom of error, which is 395. That will give you p-value. That's how you get the p-value. Don't need this one. That's how you get the p-value. I'm sorry, p-values. That p-values, sorry, I think I didn't write this. P-values extreme than probability that p-values extreme than T0. That's the probability p-value. Degrees of freedom of error. You have to do this one with in R. This is in R. You know, calculate separately, but you don't have to. So already calculated for us. Already calculated for us. I'm gonna get from both sides. That's why I double it. I'm gonna say that this area I calculate in R that area. See, 395. 395. See, in R. This is in R. See, that's the one that you see P value. See that. So, sorry. So P value. See. At the p-value, look at the p-value, extremely 0. Since p-value extremely 0, you can simply say reject H0. Since p-value is 0, see, almost 0. But when it come to here, look at here. Statement of purpose. Statement of purpose 0.75. P-value. is not extremely small. P-value is, there are three ways you can get this done. You know that. P-value you can compare with, sorry, two ways. P-value you can see whether it's extremely small or whether it's less than 0.05. See, it's more than 0.05. We had that broader discussion on why 0.05 because based on the 95 confidence, okay, level of significance will be taken into account here, 0.05. See, 0.75. See, since, see, specifically that if you're going to take into account this one, I can write over here that you can say P value for statement of purpose. I would say P of statement of purpose, SOP, which is 0.7, 0.753067, 0.753067. Greater than, see, greater than alpha. Alpha means level of significance. We know we do not reject H naught, which means beta 4. Statement of purpose is the beta 4. See, reject. That means, therefore, you can infer statement of purpose does not significantly explain the variation of chance of admit. See, you don't reject because not significantly explain the variation of chance of admit. Explain, okay? Explain. Still they don't explain. Significantly explain the variation of chance of admit. So that even though that it's already in the that this one, it doesn't say how did you know that by looking at the p-value. P-value is greater than that one. If p-value less than 0.25 or extremely smaller, these three, see, by looking at significant. See, if you reject H naught, we call the test is significant. If you don't do, we're gonna say that test is not significant. See, the test, okay, of hypothesis is not significant. You do not reject. Reject here H naught theta 4 equals 0. And I think this book has some issue, not the pen, the texture. not significant. The test is not significant. That's why we're gonna ask that eventually that when you see the, they're gonna ask that see over here this one say fit a reduced model after removing expanded variable that you believe do not contribute to the model. See, out of this one, when you take that out, you don't put that one. And plus that, what I want to tell you over here that before we're gonna stop, okay, the pre, as I said, I'm gonna run one more time and say that there are so many pre's. Okay, when you run like let's say that this one, no, see. So let's say that this model, okay, just without centering or anything, with centering or without centering doesn't matter. Okay, see, then get the supernova model. See, so many pre-values. See, how many f values for each and every one correspond to. But major one is this one. Okay, major one is this one. Others you don't have to worry about that one. Those are sequential, that sequential f, sequential pre, sequential p. So you don't have to worry about them. So I'm going to do some kind of adjustment over here. Really, I have to mention pre for, I would say pre for model. Okay. Pre for model. Okay. Make it clear. Otherwise, it's not clear. Here, again, F for model and degrees of freedom for model again. Okay. And p value for model. There are so many p values. B naught is it's okay, no? B naught is okay. Or degrees of freedom. I'm sorry. P for the model. B naught value we can put. Yeah, there are two. Okay. Okay, I'm gonna go back. Not degrees of freedom. Okay. Okay. This is what we meant. The degrees of freedom related to F. How do you get the degrees of freedom? This degrees of freedom you need, how do you get this value? F value. You divide this by this one, no? That one. Sum of squared model. Okay, don't worry about the sequential ones. Okay, sequential ones. I'm talking about this. You get sum of squared regression divided by degrees of freedom will give you this one. Right. And sum of squared error divided by degrees of freedom, its corresponding degrees of freedom will give you mean squared error. See? And then later on, you're going to divide this by this. Mean squared regression divided by mean squared error will give you the major F. This guy. That means you have a 2 degrees of freedom. So I have to do adjustment here to here degrees of freedom related to model F. Model F. Model F. Say like that. Model F. Okay, make it clear otherwise. Model F. So that means this one. See, this degree of freedom and this one. You normally know that one, okay? Like this one, and we can see. You can say sum of squared regression, see, divided by degrees of freedom of regression will give you mean squared regression, see, in this one. And the similar fashion, mean squared error means, see, sum of squared error divided by degrees of freedom of error. So So f is nothing but mean squared regression divided by mean squared error. The same as sum squared regression divided by degrees of freedom regression divided by sum squared error divided by error. This one means squared error. Who has some issue? I think mean squared regression. Regression, degrees of freedom, mean squared error, mean squared error. And this is nothing but SSR divided by degrees of freedom of regression divided by sum squared error divided by degrees of freedom of error. So this one and this one are the one that taken into account. So normally when it comes to this, we're going to call this one numerator. Numerator, this one called, okay. Okay, 1 second, okay. And I can stop over here. This one, so the degrees of freedom of the numerator, I'm going to call now. Degrees of freedom of denominator is nothing but degrees of freedom of regression. Those are the two that we are expecting. And then, yeah, denominator. Those are the two. Regression one, error one. That's right. Sequential one, don't take in error. Okay, this one error. Okay. So that's the one should come over here. So this here put the degrees of freedom of regression, degrees of freedom of error. Even though you have a sequential one, don't take into account sequential one. That's what I'm trying to say here. You don't need that. Okay. So the same thing related to model. Okay. That's it. So I'm gonna go ahead and then stop over here. We can continue the same discussion and then those are the interpretation. I think pretty much all interpretation. And then you pick that definitely you saw that sum of squared, sorry, statement of purpose not going to work over here. Then take that out. You don't fill in that part. You fill this one again for that reduced model. It's called the reduced model. The first one is called the full model. See, this is called the full model. This is called the full model. This is called the reduced model. The interesting part that how we keep doing this. Which model is the best model? First model with the 4 explanatory variable or the reduced model with the only those contribute to the model. How many parameters are in the multiple regression? How many parameters in the reduced model? You know that discussion, we already did that one. How did the parameter estimate change as a result of removing explanatory variable? Why do you believe this or that? How did your interpretation change as a result? So I think we're going to talk about that one in detail. Later on, then extra credit we can get that if somebody, the coefficient go to that particular person and then do the prediction and then we can continue from discussion. Okay. So I'm gonna go ahead and stop over here. Do you guys have any questions? Anything? If not, I'm gonna let you go. That you guys have a good night, stay safe, be well, and then see you guys on Wednesday. Okay, take care. Thank you very much. Have a good night. Thank you. Oh yeah, go ahead. Yeah, go ahead. Hey, John, go ahead. Yeah, you can, yeah. Again, okay, I'm gonna give a one more week. Okay, let's do, yeah, okay. The one more week like last time. Oh, I'm sorry, the last time you were not in the the last day to submit pretty much everything. I'm gonna give an extra 1 week, that whole next week as well. So this week that we are supposed to finish everything by next Thursday, means 19th. So you're supposed to turn in all, pretty much all the assignments by 27th, November 27th, okay? November 27th. November 27th. Yeah, that's the day. Yeah. Oh, thank you. Thank you very much. That's okay. Thank you. Oh, another course. Still you have the problem? Ex- Oh, okay. Okay, I'm gonna show you that something, okay, before I leave. Okay, 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 this one. Let's go to the textbook on my side, okay? And that's why I actually contacted that the people at the Coast Guard. When I send an email, they're gonna answer me like in 2-3 days. They're not very efficient or promptly answer anything. Pretty much, I mean, like I check all the emails like every 30 minutes. But okay, let's go to here, student resources. Okay. No, you might have a problem, John, because that the thing is that that book different. Okay, let's have a look at it. Okay, it'll be real quick. Look at on my one. Yeah, look at this one. You don't have to worry about that for each and every question that submitting that submissions. We don't take that one into account. Mainly, I taken into account the 4 assignments, midterm, final exam, and 3 quizzes. That's it. Don't worry about that, even though that you didn't get a chance to submit. Then okay, don't worry about that. See, okay, don't worry about that. See, look at this one. On my side, look at what I have. Okay, look at. I have an NR 605. Let's say I open this one. Look at what we see. See, yeah, okay. But the thing is, do you see this book actually? Okay, this is the difference they're gonna happen from here. Okay. Oh, I'm sorry. I'm sorry. I'm sorry. I'm gonna share the screen. Yeah. So this is what I'm talking about. After chapter 8, up to chapter 8, they have a missing chapter in review question. Okay, this one. Look at this 9-2. Okay, in this book. See, I just click on the first one. See this one. I click on this one, NR 605. See, that's the same book I have. That's the book that you should see on your side. This book, see, especially that you can see the difference starting from chapter. If you see that chapter exercises starting from chapter 9, and that's topic, see, model comparison with the ratio, as I mentioned in my today announcement, is good if you can see that. On the other hand, let's say I'm going to open this one. Okay, let's see what they have. Okay, after chapter 9. Let's see. Look at chapter 9 now. Look at no more questions anymore. They have revised the textbook. See, they have revised the textbook. Is that the one you can see? You had the first one? Yeah, first one. Yeah, exactly. Yeah, first, the one that I showed you. Yeah, if you have that one, that's good. If you have this one, no, you don't have to worry about this one at all. That's what I'm telling you. This one has some kind of a drastic changes they have done after chapter 9. See, look at, they call the logic inference. And the chapter 10 also different. See, chapter 9, 10, they don't even have a chapter in questions. I don't know what reason, I don't know in this on this earth that why they did something like that. Because a student can have a practice by having those questions, but they took that off. But as long as you said that, as long as you have the first one, you're good. You're good, this one. This one pretty much same like this one. It's good, okay? Yeah. No, it's not optional. You have to do that one. It's finally you can see, that's chapter end questions. It's not optional. You just do it. Just okay. Don't worry. Okay. That's okay. Okay. Any more questions? Anything? If not, I'm gonna let you guys go. Okay. You guys have a good night. Okay. Thank you. Thank you very much. Okay. And good night. Okay. See you guys on Wednesday and Thursday. Okay. Take care. Bye bye. Thank you. Thank you very much. Thank you.